Alright, so to walk through the extra credit problem, I have the problem written over here, and over here I have what y will equal. And here, first we're going to want to find y prime, which this constant will stay as a constant, or it'll go to 0. So then the first term will actually be c1, which will end up being c1 plus 2c2x plus 3c3x squared, and so on. So then coming back over here, we're first going to want to set this up to look like a power series, knowing what we know y equals, which, for refresher, y is equal to the summation of cn x to the n. So y double prime, prime, and y, combining them, will end up being the summation, starting at n equals 2, because this is the second derivative, of n minus 1, c to the n, x to the n minus 2. And then since this is minus 2x, I'm going to add the 2x there, so minus 2x. And then we'll do our second summation, this time starting at n equals 1 because it is our first derivative of n c to the n x to the n minus 1. And then we know our single y has an 8 in front of it, so it's going to be plus 8. And then our final summation, this time n is going to be at 0, of cn x to the n. And then this will all be equal to 0 because that's what we have over here. Now from here we have to make these n's all match, and we have to make all the x exponents match. So to do that, we are first going to make this one start at n equals 0. So doing that, if we want n to equal 0, that means that all of these n's are going to have to actually equal itself minus 2. So that means plus 2. So that means instead this is going to be n plus 2. N minus 1 will turn into n plus 1. And then cn plus 2. And then n minus 2 plus 2 those are going to cancel out, so it'll just be x to the n. And then this one will first, let's just start by distributing this minus 2x. I'll keep the minus on the outside, but it'll be 2n c sub n, and then distributing the x in, we'll just be adding 1 to the exponent, which will make the minus 1 cancel out, so it'll just be x to the n. And then this final one, I'm just going to distribute the 8 in. So this one will just turn into the summation 8cn x to the n. And then this will all still equal 0. Now we can see that this first part and this second part both start at n equals 0, and the power of x is the same at just x to the n. So that means that we can combine these into one summation. So I'm just going to erase this, and I can just grab this, duplicating it. I'm actually going to leave the x to the n out and just add 8cn, and then x to the n on the outside. And then minus our second one, which is minus n equals 1, 2n cn x to the n. And then this still equals 0. So now we're just going to want to make this full piece start at n equals 1 by pulling out the 0 term. So when n equals 0, we're just going to plug 0 in for every n that we see. So it's going to be 0 plus 2, which is 2. 0 plus 1 is 1. C to the 0 plus 2 is c sub 2, plus 8 c sub 0. And then x to the 0, which is just 1, so I'll just erase that. And then we'll add the real summation in itself, this time starting at n equals 1 since we pulled out the 0 term. And then it'll stay the same, so n plus 2, n plus 1, cn plus 2, plus 8cn. And then I'll just grab this. Now we can see that these both have x to the n, and they both start at 1, meaning we can combine them. So 2 times 1 is just 2, so this will be 2c2 plus 8c sub 0 plus the summation starting at n equals 1 of this whole thing minus 2n cn and then x to the n on the outside, and it still equals 0. So we know that this needs to equal 0 and this inside part needs to equal 0. So 2c sub 2 plus 8c sub 0 equals 0. And then this whole inside part is also going to equal 0. Now here, I'm going to solve for c n plus 2. So to do that, I will first move this all over to the other side. So equals 2n cn minus 8cn, which I'm actually going to pull the c sub n's out. And then we'll just divide both sides by the n plus 2, n plus 1. So cn plus 2 will be equal to, and I'll pull a 2 out as well, so 2cn n minus 4 over n plus 2, n plus 1. So now we know what c sub n plus 2 is equal to. And here, let's just simplify this, and with a little algebra, we'll just know that negative 4c sub 0 is equal to c sub 2. Now, I'm gonna make a little chart to find these c sub n plus 2. And then here, to make this easier on myself, I'm gonna pull this cn out, and you'll see why later. So let's go up to around 6 or 7. So n equals 0, 1, 2, 3, 4, 5, 6, 7. Sorry about the siren. So starting with this c sub n plus 2 of n equals 0, that means it is c sub 2 is equal. And then just going up, so it'll be c3, c4, c5, C6, 7, 8, and C sub 9. And now I'm just gonna do this part by part. So 2, 0 minus 4 is negative 4. And then divide that by 0 plus 2 is 2 times 0 plus 1, which is 1. Then it's going to be 2, 1 minus 4, negative 3 over 3 times 2. And 2 times negative 2 over 4 times 3. And we'll just continue this on the way down. And then the last part will be the C sub n part. So this will be C0, C1, C2, C3, 4, 5, 6, and 7. So now we see starting at C sub 4 in this line here, we see this is being multiplied by C2, but C2 is up here. So that means that we can replace this C2 with the actual value of C2, which we know is up here. So going through to do that, this will be negative 4 over 4 times 3 times negative 8 over 2 times 1, C0. And I'm just going to do this all the way down, going back and reverting to these C's that we see up here when we see repeating. Because this is being multiplied by 0, this whole thing will just be 0, but we'll make sure to just note that it is going to be C0. And then finally C9, 6, times C7, which we see up here. So now we have all of our values, and we can see a pattern here. So we see 4, 3, 2, 1, 5, 4, 3, 2, 7, 6, 5, 4, 3, 2, which if you're familiar with factorials, you will see as a factorial. So to simplify these, let me move this all over. And I know we cut off the C1 here. So this will end up negative 4 times negative 8 over 4 factorial C sub 0. This one is equal to negative 2 times negative 6 over 5 factorial C sub 1. This one is equal to 0, C sub 0. This one is equal to 2 times negative 2 times negative 6 over 7 factorial C sub 1. This one's also going to be equal to 0, C sub 0. And then finally, this will be equal to 6 times 2 times negative 2 times negative 6 over 9 factorial C sub 1. So we see after this value here, which is C sub 4, all of the C sub 0 values will be equal to 0. So now we can set this up in this form that we talked about up here, now that we know all of our values. And I'm now realizing that I forgot to mention with these initial values, let's solve for those before we do that. So if we know that y sub 0 is equal to 9, that means that our first constant is going to be right here, because all of these x's, if they're all 0, we'll cancel everything out except for the constant value, which means C sub 0 is equal to 9. And if y prime of 0 is equal to 0, it's the same thing. All of these x's will cancel out, so that means C sub 1 has to be equal to 0. So coming up here, we can put this in this form, which I'm going to bring down just as a reminder. And let's set up our y. So y is equal to C sub 0, which we said was 9 from up here. So 9 plus C sub 1x, which we said C sub 1 was 0. So that's going to be 0x plus C sub 2x squared. C sub 2 is going to be this one right here, which I'm realizing we forgot to simplify, so this will just be 2 times negative 4 over 2 factorial C sub 0. And this one in the middle here is going to be 2 times negative 3 over 3 factorial C sub 1. So 2 times negative 4, 2 factorial. And then this is our C sub 4. So I'm just going to grab that. I'll actually move it down here. Sorry, this second one was C sub 1, I believe. Yeah, that one's going to be C sub 1. And then this will be x to the 4th. this is going to be c sub 5. C sub 6 we said was just 0. Then we'll go on to 7. Then 8 was also equal to 0. And finally, we have 9. Which will have x to the 9 on it. Now, knowing that, I'm going to write it up here so we remember. We said C1 is equal to 0 and C0 is equal to 9. Yeah, those are right. So, with that being said, we can plug those in to this to simplify, because we're going to see that a lot actually does end up canceling out. So I'm going to grab this and duplicate it to bring it down here so we can see this more easily. Sorry about that. So, y is equal to 9, and then this 0x is nothing, so I'm just going to leave that out. And this, we can grab and then here, we know c sub 0 is 9. And then every single value with the c1 is going to end up equaling 0. Because c1 equals 0, none of these will end up being in our final answer. And we'll see that every c sub 0 value after c equals 4 is going to be equal to 0 as well. So that means that this is kind of the stopping point of our series, which means that we don't actually have too much to write out for the final answer, and we only have one more term left. And this is our final answer. So to clean it up, it's 9 plus 2 times negative 4 is negative 8 over 2 factorial times 9 x squared plus negative 4 times negative 8 is negative 28 over 4 factorial times 9 x to the 4th. And now, I'm so sorry, hold on. 4 times 8 is 32. So now this is our final answer, and the answer to our power series with the initial value condition